Hello everyone. And welcome back once again to another interesting video. In this video we'll discuss most important commonly asked Java interview questions and answers for beginners and experience. So if you are ready, let's start today's video. Question 1. What is the importance of reflection in Java? Answer. Reflection in Java refers to the ability of a program to examine and modify its own structure, behavior, and metadata at runtime. It allows developers to inspect classes, interfaces, fields, methods, and constructors, as well as invoke methods dynamically, instantiate objects dynamically, and access and modify fields, even if they are private. Reflection is an important feature in Java for several reasons. 1. Dynamic loading. Reflection enables dynamic loading of classes at runtime. This is particularly useful in applications that need to load and interact with classes that are not known at compile time, such as plugin systems or frameworks that support dynamic configuration. 2. Introspection. Reflection allows programs to examine their own structure and the structure of other classes at runtime. This introspective capability is used in various Java frameworks and libraries to implement features such as serialization, object relational mapping, ORM, dependency injection, and unit testing. 3. Runtime polymorphism. Reflection enables runtime polymorphism, where the behavior of a program can be determined dynamically based on the type of objects at runtime. This is particularly useful in situations where the types of objects are not known until runtime, such as in generic programming or when dealing with heterogeneous collections. 4. Debugging and testing. Reflection provides a powerful tool for debugging and testing Java applications. It allows developers to inspect and manipulate the internal state of objects, call private methods for testing purposes, and perform various debugging tasks programmatically. 5. Framework development. Reflection is widely used in the development of Java frameworks and libraries. Frameworks such as Spring, Hibernate, and JUnit make extensive use of reflection to provide features such as dependency injection, object relational mapping, and dynamic test case execution. 6. Serialization and deserialization. Reflection plays a crucial role in Java's serialization and deserialization mechanisms. The Java.io serializable interface uses reflection to dynamically serialize and deserialize objects, allowing them to be stored to and restored from streams. 7. JavaBeans and XML configuration. Reflection is used in JavaBeans and XML-based configuration frameworks to inspect and manipulate the properties of Java objects at runtime. This enables features such as automatic property binding, validation, and configuration management. Overall, reflection in Java provides a powerful mechanism for introspection, dynamic behavior, and runtime manipulation of Java objects, making it an important and versatile feature in the Java programming language. However, it should be used judiciously due to its potential performance overhead and complexity. Question 2. What are the different ways of threads usage? Answer. In Java, there are several ways to work with threads, each with its own advantages and use cases. Here are some of the common ways to use threads in Java. 1. Extending the thread class. You can create a new thread by subclassing the thread class and overriding its run method, which contains the code that will be executed by the thread. Then, you can instantiate the subclass and call its start method to begin execution. Here is the example of how you can use thread by extending thread class in Java. In this example, we create a subclass named myThread that extends the thread class. By extending thread, we can override the run method, where we define the logic that the thread will execute. In the main method, we create an instance of myThread and then call its start method. This starts the execution of the thread and invokes the overridden run method. 2. Implementing the runnable interface. Alternatively, you can implement the runnable interface and provide the thread's logic in the run method of the implementing class. Then, you can create a thread object, passing an instance of the implementing class to its constructor, and call start to begin execution. Here is the example of how you can use thread by implementing the runnable interface in Java. Here, we define a class myRunnable that implements the runnable interface. The runnable interface requires implementing a run method, where we define the logic to be executed by the thread. In the main method, we create an instance of thread, passing an instance of myRunnable to its constructor. This associates the myRunnable instance with the thread. We then call the start method on the thread object to start the execution of the thread. 3. Using executor service and callable. Java's executor service framework provides a higher-level concurrency API for managing thread execution. You can submit tasks to an executor service for execution, and it manages the threads for you. This approach allows for better control over thread lifecycle, task cancellation, and thread pooling. You can use callable along with executor service to execute tasks that return a result or throw an exception. Here is the example of how you can use thread by using executor service and callable in Java. In this example, we define a class myCallable that implements the callable interface with a generic type string. The callable interface requires implementing a call method, similar to Runnable's run method. It can return a result or throw an exception. In the main method, we create an executor service using executors.newSingleThreadExecutor, which creates an executor service with a single worker thread. We submit an instance of myCallable to the executor using executor.submit. This starts the execution of the task represented by myCallable asynchronously and returns a future object. We call future.get to block the main thread until the result of the computation is available. Then, we retrieve the result and print it. Finally, we shut down the executor using executor.shutdown to release its resources after the task is completed. 4. Using Java 8's completable future. Java 8 introduced the completable future class, which provides a powerful way to work with asynchronous tasks and handle their results using a fluent API. You can use completable future to perform tasks asynchronously, combine multiple asynchronous tasks, handle exceptions, and more. Here is the example of how you can use thread by using Java 8's completable future in Java. In this example, we import completable future and execution exception from java.util.concurrent. In the main method, we create a completable future using completablefuture.supplyAsync. This method asynchronously executes the supplied supplier and returns a completable future representing its result. Inside the supplyAsync method, we provide a lambda expression that represents the task to be executed asynchronously. This lambda expression returns the string result. We call future.get to block the main thread until the result of the computation is available. Then, we retrieve the result and print it. These are some of the common ways to work with threads in Java. Each approach has its own advantages and use cases, so choose the one that best fits your requirements and programming style. Additionally, Java provides higher-level concurrency utilities in the java.util.concurrent package, such as locks, semaphores, countdown latch, etc., which can be used for more advanced threading scenarios. Question 3. What are the different types of thread priorities in Java? And what is the default priority of a thread assigned by JVM? Answer. In Java, threads can be assigned priorities to indicate their importance or preference for execution by the thread scheduler. The thread scheduler is responsible for determining which thread to execute next based on their priorities and other factors. Thread priorities are represented by integer values ranging from 1, lowest priority, to 10, highest priority, where a higher numerical value indicates a higher priority. The different thread priorities in Java are 1. Min_priority, 1. This is the lowest priority value. Threads with this priority are scheduled for execution only when no higher priority threads are waiting to be executed. 2. Norm_priority, 5. This is the default priority value assigned to threads if not explicitly set. It represents normal priority and is typically used for most application threads. 3. Max_priority, 10. This is the highest priority value. Threads with this priority are scheduled for execution with preference over lower priority threads. However, thread priorities are platform dependent, and the actual behavior may vary across different operating systems and JVM implementations. To set the priority of a thread in Java, you can use the setPriority method provided by the thread class. Here is the example. The default priority assigned by the JVM to a thread if not explicitly set is norm_priority, 5. This means that if you create a thread without explicitly setting its priority, it will inherit the default priority value. It's worth noting that while thread priorities can influence the thread scheduler's decisions about which thread to execute next, they are not guaranteed to have a significant impact on thread execution order, especially in modern JVM implementations and operating systems where thread scheduling policies are complex and influenced by various factors. Additionally, thread priorities should be used with caution and are generally considered less reliable for fine-tuning thread behavior compared to other synchronization mechanisms and concurrency utilities provided by Java. Question 4. What is the difference between the program and the process? Answer. In computing, the terms program and process refer to different concepts, although they are related. Here's the difference between the two. 1. Program. A program is a set of instructions or code written in a specific programming language that performs a particular task or function. It is a static entity, typically stored on disk as a file. Programs can be anything from simple scripts to complex applications. Examples of programs include text editors, web browsers, compilers, and games. A program remains inert and does not consume system resources until it is executed by the operating system. 2. Process. A process, on the other hand, is an instance of a program that is currently being executed by the operating system. It represents the execution of the program's instructions in a specific context. When a program is executed, the operating system allocates system resources, such as memory, CPU time, and I/O devices, to create a process. Each process has its own memory space, execution state, and set of resources. Multiple processes can be created from the same program. For example, if you open multiple instances of a web browser, each instance will be a separate process. Processes are dynamic entities that can consume system resources and interact with other processes and the operating system. In summary, a program is a set of instructions or code stored on disk, while a process is an instance of a program that is currently running and consuming system resources. Processes are created by the operating system to execute programs and provide isolation and resource management. Question 5. What are the differences between constructor and method of a class in Java? Answer. In Java, constructors and methods are both members of a class that serve different purposes. Here are the key differences between constructors and methods. 1. Purpose. A constructor is a special type of method used for initializing objects of a class. It is called automatically when an instance of the class is created using the new keyword. A method is a regular function defined within a class that performs some specific task or computation. Methods are invoked explicitly by calling them with appropriate arguments. 2. Name. The name of a constructor is always the same as the name of the class. A method can have any valid identifier as its name. 3. Return type. Constructors do not have a return type, not even void. They cannot return a value. Methods have a return type, which specifies the type of value returned by the method, or void if the method does not return anything. 4. Invocation. Constructors are invoked implicitly when an object of the class is created using the new keyword. Methods are invoked explicitly by calling them using an object reference or class reference. 5. Usage. Constructors are used to initialize the state of objects, set initial values to instance variables, and perform any necessary setup when an object is created. Methods are used to define behavior or operations that objects of the class can perform. They encapsulate the functionality of the class and are called to perform specific tasks. 6. Overloading. Constructors can be overloaded, meaning a class can have multiple constructors with different parameter lists. Methods can also be overloaded, allowing multiple methods with the same name but different parameter lists. 7. Accessibility. Constructors can have access modifiers, public, private, protected, or default, but they cannot be declared static or abstract. Methods can have access modifiers, public, private, protected, or default, and they can also be declared static, abstract, final, or synchronized. In summary, constructors and methods are both members of a class, but they serve different purposes and have different characteristics. Constructors are used for initializing objects, have the same name as the class, and are invoked implicitly when objects are created. Methods, on the other hand, define behavior or operations of objects, have a return type, and are invoked explicitly by calling them. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.